So first of all, hello and welcome to the last chapter of physics, that is named as radioactivity, which we will be discussing or rather start discussing today with our first lesson in radioactivity. It is the last chapter in Icse syllabus in your textbook, and very often it happens that we tend to lose interest at the fag end of the syllabus, and that should not happen. We should go ahead with the same intensity as we started in the fourth chapter and complete this very easy and scoring chapter in a meticulous way. That is the way we always do. So without wasting any further time, welcoming you to the chapter called radioactivity with a very beautiful looking picture with not so beautiful outcome. Okay guys, so let us see what is radioactivity and what it can cause. Yes, it can cause severe amount of destruction, and that is not what we want. While we talk about this destruction, it is imperative that it is having high amount of energy. So this high amount of energy, if we can use in a good way, then definitely it will serve the mankind, and if we use in a wrong way, then it is going to end the mankind system at all. There will be no human beings or any life present on this mother earth if we do not use this energy in a good way. So with that you can understand the importance of this chapter. It can be used in a bad way, it can be used in a good way. Whatever way you use it, it is going to cause a major effect in our life. Coming down to Icse syllabus, our first topic in radioactivity is atomic structure. That is, we have to understand the structure of atom. I know many of you have studied this chapter in class 9th, but I would like to say you that even if you are in class 10th or even in higher classes, let us revise the basic atomic structure. This is a structure of atom, as we all know. And in the structure we can understand that this part is nothing but nucleus. This is the nucleus of the atom, and this is orbit, this one is the orbit. In the nucleus, this blue colored ones, the blue colored circles are proton mentioned over here, the red colored ones are neutron, and the ones which are revolving along the orbits are called electrons. So atoms consist of mainly particles, that is electron, proton and neutrons. In this, these protons and neutrons together remains in nucleus, and hence they are called nucleons. They remain in nucleus and hence they are called nucleons. Electrons revolve around the nucleus in some specific orbits. These are the orbits we are talking about, these are the orbits. Okay. These orbits are also called energy levels or shells. Okay. Also called energy levels or shells. Why these are called energy levels? Because each shell has specific amount of energy. Each shell has specific amount of energy. These points are very important, please write it down. These shells have specific amounts of energy. While moving in this orbits, electrons do not radiate any energy. What does this mean? It means that while these electrons are going through this orbit, each orbit represents a specific amount of energy, and that energy is the energy of the electron. These electrons, while moving around the nucleus, doesn't lose any energy. That doesn't lose any energy. Here from we get this theory of Bohr, from where we have developed this basic atomic structure, and from there this is one of the Bohr's postulate from where we are studying atomic structure today. Electrons get filled up in orbits in the following rule, 2n square. that is also Bohr-Bari rule. And what does this mean? Each orbit named as K, L, M, N, I hope you guys have heard it, having orbit number 1, K means orbit number 1, L means orbit number 2, like that. So, if there is orbit number 1, it will go 2 into 1 square. So, maximum number of electrons that can be accommodated in orbit number 1 will be 2. In orbit number 2 will be 2 into 2 square, that is 2 into 4 will get 8 and so on. So, these are all basically revision of class 9th level atomic structure, which we need to do as a part of the syllabus in this radioactivity. Okay. So, I hope this part is clear and we can move on to the next slide. What do you say? Please write this down. You may pause the video and write this down along with me. Okay, done? Okay. So, overall what we have studied, in an atom it contains nucleus, nucleus contains protons and neutrons, and other part, that is the extra nuclear part, is called orbit, and in orbit we have electrons. So, we will be going, or we shall delve into each particle at this point of time, and we have to know what are these particles and what does its charge and mass, that much. Nothing more into it, it is basically known to you. In atomic structure you have studied it. So, first of all we are going to proton. So, in case of proton, see, in case of proton, what is the charge of proton? Charge of proton is +1, elementary charge. What does elementary charge means? Elementary charge means 1.602 into 10 to the power minus 19 coulomb. This is elementary charge. Okay. So, this amount of charge is present in proton. Proton is having a positive charge, is a positively charged particle, that we have to remember. Okay. And what is its mass? Its mass is atomic mass unit. What is AMU? Have you remembered AMU or you have forgotten? AMU is also mentioned as 1 U. Okay, U. Nowadays it is written as U, not AMU. So, 1 U is equal to 1.67 into 10 to the power minus 24 gram. This is 1 AMU. Okay. So, this is the mass of proton. Now, we will be going into neutrons. So, what is neutron? Neutron having no charge at all, and its mass is also approximately equal to that of proton, but you need to know that neutron's mass is slightly higher than proton mass. So, please write this down. Neutron's mass is slightly higher than proton. So, proton is 1672 I guess, and neutron is 16749, like that, okay, into 10 to the power minus 24 gram. Noted everything, proton or neutron is clear. So, this much amount of information you need to know, that what is the charge of proton and what is the mass of proton. What is the charge of neutron? It is a neutral charge, that means it does not have any charge at all, it is completely chargeless, and mass is almost equal to proton, but however you can have this, that neutrons has having a slight higher mass than proton. Now, coming to electron, one of the most used part in chemistry, as we all know, in chemistry electron plays a major role in most of it, except the physical chemistry part. In some part protons also plays some role on it, but that is also a part of physics that is inside the chemistry, that is the nuclear chemistry we call that. Okay, but that nuclear chemistry we are studying at this point of time in the name of nuclear physics. Okay. -1 elementary charge. What does this mean? The charge is minus 1.602 into 10 to the power minus 19 coulomb. Clear? And what is its mass? Its mass is very less, very less, 1 by 1836 AMU, much lighter than proton or neutron, much lighter than proton or neutron, and as you can see, this is 1 by 1836 times of an already very less mass that we discussed over here, 1.67 10 to the power minus 24, and the mass is 1 by 1836 times of this. It is already minus 24, and the mass comes out to be, mass of electron 9.1 into 10 to the power minus 31 kg. In grams it will be 9.1 into 10 to the power minus 28 gram. Okay, please note this down. All important information, especially as per your requirement, is being put in with the fill, with the understanding that you require for this chapter, because not only the informations are important, but along with that you should love the subject and the chapter, so that you can have an intimate relationship with the chapter and hence you can succeed. Okay. Okay. Next is, after we have already known proton, neutron and electron and the basic idea about those, we need to know what is atomic number. And what is atomic number? Atomic number is nothing but it is the number of protons in the nucleus. And what is it? Number of protons in the nucleus. I have never said it is equal to number of electrons. I have said atomic number is equal to number of protons in the nucleus. Okay. So, Z is equal to number of protons, not electrons. Now, you can say that can be equal to electrons also, but however, protons are not always equal to nucleus, equal to electrons, sorry. Protons are not always equal to electrons. There are cases protons are unequal to electrons in case of charged species. Like if I take say Na plus, so Na is having an atomic number of 11, that means it has 11 protons, but plus means it has donated 1 electron. So, originally sodium is having same number of electrons as protons. Originally sodium was having same number of electrons as protons, however, it has donated 1 electron, now it has 10 electron. So, here in the charged species, proton is not is equal to electron, protons is more than electron in this one. If it is Cl minus, then this is 17 protons, 17 proton, atomic number is 17 protons. However, chlorine, though having 17 electrons, it takes another electron from outside and it becomes negatively charged, and it is having 18 electron. Again, proton is not is equal to electron. So, in charged species, proton is not equal to electrons. So, you need to remember, you need to understand, you need to observe, and you need to get the feel of these things. What it determines? It determines the element to which the atom belongs. It determines the elements to which the atom belongs. So, atomic number gives us what information? Which element is it? This atom is of which element? Is it hydrogen? Is it nitrogen? Is it oxygen? Or is it something else? Okay, that is what atomic number gives us. It gives us the element to which the atom belongs. Elements are defined by number of protons in their atoms. Yes, correct. Because number of protons will be the atomic number, and no two elements will have same atomic number. This is important. You should write this down. No two elements will have same Z. Okay. Next, in a neutral atom, atomic number also equals the number of electrons. Correct, because in neutral atoms, what happens? In neutral atoms, protons become equal to electrons in neutral atoms. So, definitely they will be equal. So, that is what atomic number is, and you need to keep this small information in mind. Along with that, we will know what is mass number. What is mass number? Mass number is the total number of nucleons. That is, what are nucleons? Protons plus neutrons are called nucleons. So, total number of protons and neutrons is called mass number, and it is represented by a symbol A. So, atomic number was represented by symbol Z, mass number was represented by symbol A. Okay, you have to remember this also, because many times these notations are important. Okay. The mass number gives the approximate measure of total mass of the atom. See, mass of an atom is mass of the particles. Mass of atom is equal to mass of proton, mass of neutron and mass of electron. Now, we already know that mass of electron is 1/1836 times of mass of proton. So, this is very much negligible, because this is very less compared to proton or neutron. So, this one will take as 0, we will ignore this and we will take only the mass of proton and neutron while finding out the mass of an atom. So, whenever it is said that find out the mass of the atom, you need to consider only the mass of the protons and the mass of the neutrons. There is no requirement to consider mass of electron, because the mass is minuscule with respect to protons or neutrons. Okay guys, so let us proceed. So what did we get at this point of time? We got that Z is equal to Z, that is atomic number is equal to proton number and mass number is equal to proton plus neutron number. Now if anybody says that find out the number of neutrons, then how will you find out the number of neutrons? You will find out the number of neutrons by a simple formula, that is mass number minus atomic number, because mass number is P plus N and atomic number is P. So if you subtract Z from A, that means P will get cancelled out and you will get only N, P plus N minus P. So P will cancel out, you will get N, that is A minus Z. Mass number is A and this one is Z. Okay. So this is how you will calculate number of neutrons. I know many of you have done this in chemistry in class 9th and every one of you are very intelligent and remembered everything, but there is no problem practicing it again, right. So here we are going to practice it again. So this is how the notation or the symbology defines. So this is an element X. So in this in the bottom portion you will get the atomic number, in the top portion you will get the mass number. This is how the question will come. So you have to calculate, say, proton, neutron and electron. So in proton you need not think much. In proton it is just the atomic number 17 over here and 15, done. Neutron, how will you find out neutron? Mass number minus atomic number, 40 minus 20, 20, 35 minus 17, 18, 31 minus 15, 16. Okay. And next is electron. See, normally electrons are equal to protons or atomic number, that is in case of neutral atom. So this is a neutral atom, see there is no charge, so this will be 15 itself. However, this one, though it has 20 protons, it will not have 20 electrons because 2 electrons are donated. So if from 22 electrons are donated, then only 18 electrons will be there. So 18. Here it has accepted 1 electron. Originally it was chlorine has 17 electrons. By accepting another electron, chlorine will have 18 electrons. So by this we have also practiced the calculations of neutrons, protons and electrons. I hope each and everything is clear up till now, and we move on to the next topic. Very important topic, isotopes, isobars and isotones. It is an important topic with respect to atomic structure of the atom, definitely. So first thing we have to understand what is isotope. See, isotope is atoms of same element having different mass number and same atomic number. And as here the atomic number is same, so definitely the element will also be same. As the atomic number is same, definitely element will also be the same, right. So here if you see, we have taken one example of isotope over here, this one. This is 3 naturally available isotope of hydrogen. There are other isotopes of hydrogen also, but those are synthetic. These 3 are naturally available. So within this is very common, this is protium, that hydrogen that has no neutrons. Very often it is asked in exams by your teachers that name an element which has no neutrons. So you have written hydrogen, you should have written the answer as protium, at least hydrogen in bracket protium, correct, because now you know that there are isotopes of hydrogen like deuterium 1H2 which has a neutron, which has a 1 number neutron, right, and there is a tritium which also has neutron, that is 2 neutron. So these 3 are the isotopes of hydrogen. All these have same atomic number, but the mass number is different, correct. Here if you see one thing, only tritium is radioactive, protium is not radioactive, deuterium is also not radioactive, only tritium is radioactive. Many at times maybe you have already thought that except protium other 2 is radioactive. No, my dear friends, only tritium is radioactive, only tritium is radioactive, written in very bold letters in this note, very nicely written, so that everything can be directly grasped into your brain. Which is radioactive isotope of hydrogen? Tritium is the radioactive isotope of hydrogen. Okay. C14 is radioactive. Where from this C14 came up? Let us see this one. Okay, this one. Carbon 12, carbon 13 and carbon 14. There are 3 isotopes of carbon in which carbon 14 is radioactive, used in radiocarbon dating. Carbon dating method is very much widely used in finding out the age of fossil fuels. All these dinosaurs and these stories and movies on dinosaurs wouldn't have been made if this C14 wasn't there. This is the responsible person for all these dinosaurs. No, dinosaurs were there, but these movies and these historical facts and all these scientific biological rather finding out which fossils is of which element animals were all coming from this radio 14 dating, that is due to carbon 14. See here another very important thing, chlorine. Chlorine has 2 isotopes, Cl35, this is around 75% in this earth, and Cl37 is around 25% in this earth, and both of them are stable isotopes, not radioactive. Both of them are absolutely not radioactive. Cl17 is not radioactive, okay, which has the largest number of isotopes. Important point, that is why it has been again written very perfectly in the note. Tin has largest number of isotopes, 10 number of isotopes tin is having. So, as you can see over here, it is written so that it gets directly set onto your brain. Okay, छाप देने का ऐसे. Tin has 10 isotopes. Okay, last but not the least, uranium 238 and uranium 235. When we started this video, those facts wouldn't have been true if there was no this element U235. Both of these are radioactive and these are used in our nuclear reactors to produce power, which is a very good use of this huge amount of energy, and we should not use that only for making atom bombs. I still remember one of my friend in an interview, they asked, why do you want to join this company? I am not naming the company. My friend answered that I want to make atom bomb. So it is nice to have such kind of enthusiasm, but when we grow up we understand that energies can be used in much better fashion for us and everyone around us rather than only bombs. And that person at this point of time is a scientist doing some really good jobs around the world. He is one of the 100 scientists in this world, and I am very much thankful that I had studied with him. That's what I can say. Okay, both of these are radioactive, brain may set. Next, stability of isotopes. See, all isotopes are not stable, and that is why they are radioactive, very common. So, at this point in up to your class 10th level, what knowledge you require, and if you want to know it little bit extra, that has also been incorporated over here. If neutrons and protons are nearly equal, then nuclei tends to be stable, okay. But if neutrons are much larger than the protons, then the nuclei tends to be unstable. So, this statement you are going to find in any class 10th level books, and this is what you should know. However, this is not universally true, so that is why I have added this word called tends in both the cases. See, their stability is basically determined by ratio of neutron by proton basically. So, when there is low atomic mass, that is up to element number 20, the ratio is 1:1. So, if it crosses 1:1, there is a tendency, like carbon 614, there is a tendency of becoming radioactive. However, for heavier elements, this ratio will go up to 1.5:1. So, for heavier elements, it can go up to 1.2, 1.3 also, even up to 1.5 it may not be radioactive. Okay. So, after lead is having atomic number 82, after that in periodic table nearly all the isotopes are radioactive, okay, nearly all the isotopes. So, you have to know this. And this one is the band of stability. So, here everything is given. I have taken this from a US University journal. So, various, which material is fissile, that is they will cause fission, which will give alpha, which will give beta minus, beta plus. So, there are many particles. This is just for your interest, this is higher physics. So, this is a kind of curve, this is called band of stability, from which you can identify that which the element you are dealing with will fall under which kind of, either it will fall under radioactive region or not, or it is stable, or which type of radiations they are going to emit. So, this is from where you can get it, nothing else. Okay? This is called band of stability. However, at this point of time in class 10th level this is not required. Even in class 12th level a very simple curve is given in your book, that will be more than enough. This kind of aggregated curve is not required. Okay. So, as it is written over here, the details of this are a matter of high energy physics and there are many rules for predicting stability. Okay. So, except this point, I will say except this point you can ignore this slide. Okay. Coming to our last topic today, isobars and isotones. Isobars, what are isobars? Isotopes were same atomic number, different mass number. Here the atomic number is different, mass number is same. So, if you see this, atomic number is different. So, there are different elements, but mass number is same. Similarly, over here also mass number is same, atomic number is different. Isotones, elements having different number, same number of neutrons. Isotones, iso means same and tones means number of neutrons. Okay. So, here also if you see, how will you find neutrons? Mass number minus atomic number, 23 minus 11, 12, here 24 minus 12 is also 12, 39 minus 19 is 20, 40 minus 20 is also 20. So, this is how we have completed the structure of atom, the first lecture on radioactivity. Okay. And from here on we are going to go in depth into radioactive radiations and what is the difference between a chemical change and a nuclear change. All this we are going to go into very shortly in next lectures. Day by day it is going to come up. Till then, please study hard and write down each and everything that has been taught, and each and everything which have been said to be ignored in various cases, please ignore that. This is only for your good. With that, thank you very much. Good night. Goodbye.